Hello students, I am Tejaswini, lecturer in ENC, SJ Government Polytechnic, Bangalore. And in this session, we are going to know about the PLC, that is Programmable Logic Controller. The first unit in this subject is Introduction and Architecture of PLC. Okay, so what is the course objectives of this subject? That is, after learning this subject, what you're going to understand or what you're going to learn after knowing this subject. To understand programmable logic control, that is, what is PLC, what is the architecture of PLC, okay, and you'll be using here ladder programming, okay, programming and ladder diagrams to implement in engineering applications. You learn the ladder programs here, how to write a ladder diagram for any application and all. By after learning this subject, you'll be able to write the programs. Okay. In today's session, we are going to learn what is PLC, why we need PLC, what is the historical background, that is how it developed, how it got developed, what are the main branches of the PLC, what are the main areas of application, then block diagram of PLC, then components of PLCs. Okay. What is PLC? First of all, what is the full form of PLC? PLC is Programmable Logic Controller, that is PLC. See, this is your PLC looks like. Understood? So we'll see the definition of the PLC. PLC, it is a user-friendly and microprocessor based specialized computer that carries out control functions of many types and levels of complexity. PLC, it is also it's like your computer only, but it is a specialized computer. Understood? Its purpose is to monitor crucial process parameters and adjust process operations accordingly. The main purpose of the PLC is to control the operations, process parameters and operations. It will control the process parameters as well as if it want to adjust any parameters, that also this PLC will do. It can be programmed, controlled and operated by a person unskilled in operating computers. Understood? So your PLC is a user-friendly microprocessor based specialized computer that carries out control functions of many types and levels of complexity. Understood? If you see the block diagram here, this is your the PLC. For your PLC, you'll be having the inputs and it is the outputs, and PLC you'll be having the microprocessor, the program which will be storing here. Understood? We will see a simple example where the PLCs are using. This is one is a simple example that is the gate control. If you see the diagram here is this PLC will be there. It will sense a vehicle at the entrance or exit. Understood? And open and close the gate automatically. Okay. When the vehicle will come, here it will sense that a vehicle is coming, then this will open the gate. If there is no vehicle, it will closes the gate. The current vehicle, see even how many vehicles have gone, have come and all, we can keep a count on that by using a simple counter. Using the programming, that is in your ladder diagram. Next one is other simple example, that is your conveyor system. Here PLC can be used to start or stop latching logic for motor control. Counters can be used for monitoring product amounts for the conveyor system. I think this one you have seen there in your airports and all. Okay, in airports and in big this one commercial places and all. Here they'll be using this conveyor system. Understood? It will sense this. If any luggage is there, then motor will move. Okay, if not, it will stop. And also it will keep the count of the amount of luggages that has come by using a counter in the program. And why PLC? Because before PLC we were using relay logic. Then why we need to go for PLC? Okay. Using PLC, we can reduce the human efforts. First thing. Next one is to get maximum efficiency from machine and control them with human logic. If human efforts are reduced, obviously the maximum efficiency will be there because everything is controlled by your system. Accuracy will also be good. To reduce complex circuitry for entire system. If you are going for relay logic, for complex circuits and all, it is very difficult. Okay, and it will occupy more space. But using the PLC, it will occupy a less space, and even complex circuits you can handle very easily using PLC. To eliminate the high costs associated with inflexible relay controlled system. In relay controlled system, whatever the components we are using, okay, for larger systems, the cost will be more. But in case of PLC, even for larger systems also, the cost will be less using the PLC. Okay. Next, historical background. How PLC developed. Understood? So before PLC got developed, all were using the relay logic control. Relays they were using, it is electromechanical relays. Okay. So first in 1968, who is the father of PLC? Father of the PLC is Dick Morley. Okay. In 1968, the Hydromatic division of the General Motors Corporation, they specified the design criteria for the first programmable controller in 1968. Okay. The primary goal is to eliminate the high costs associated with inflexible relay controlled system. The controller had to be designed in modular form so that sub-assemblies could be removed easily for replacement or repair. First, initially, the modular PLCs. In the modular PLCs, what all components are independent to each other. Okay, we need to manually connect all the components and then it will form the PLC system. But in future, if you want to add any IO devices or memory, you can add to this modular PLCs. Understood? And if any error occurs, any problem occurs also, you can easily remove only that part of the module and you can repair and again you can fix it. That is very easy in case of PLC. But in case of relay, if any error occurs in case of relay, you need to go to the factory floor. Then there you need to check where the fault has occurred and then you have to repair it. Okay. Then it takes so much of time in case of relay logic control. The control system needed the capability to pass data collection to the central system. The system had to be reusable. Using the PLC, you can change the design as many times as you want. But in case of relays, changing the program is reprogramming is very difficult. The method used to program the controller had to be simple so that it could easily be understood by plant personnel. PLC is a very easy programming language. In PLC, we are having different programming language like FDB, that is functional block diagram, your instruction list and your ladder logic. But commonly used programming languages are functional block diagram and your ladder programming. And how this program controller developed, that is your PLC. First in 1968, programmable concept was developed. Then after that in 1969, hardware CPU controller with logic instructions, 1K of memory and it was having 128 IO ports. Okay. Then 74, use of several processors within the PLC. Then the so many functions were also incorporated, that is like timers, counters, arithmetic operation, 12K of memory and IO points were increased, that is 1024. 1976, remote input or output systems introduced. Microprocessor based PLCs are also introduced. So after the advent of microprocessor, the PLCs they developed very fastly in the industries. 1980, intelligent I/O modules developed enhanced communication facilities, enhanced software features, use of personal microcomputers as programming aids. 1983, low-cost small PLCs introduced. 1985, networking of all levels of PLCs, computer onwards and machine using the software. Initially, only it was with this Modicon company, okay, but after that, only the proprietary it has with the Modicon. Then gradually it becomes unproprietary. Then it all the so many companies they started developing the PLCs. And today we are having so many brands of PLCs in the world. If you consider for the American side, we are having Allen Bradley, Gold Modicon, Texas Instruments, General Electric, Westinghouse, Cutter Hammer, Square D. These are some of the brands of PLC of American. And if you go for European, we are having Siemens, Knocker and Two, Moeller, Fessel Mechanic. These are some of the brands of European. And if you go for Japanese, we are having Toshiba, Omron, Fanuc, Mitsubishi, etc. These are some of the main brands of the Japanese. Understood? But in generally today, Allen Bradley is the most used one. Understood? And Siemens also, and then Toshiba, Omron. These are some of the main brands of the PLC. And next, where these PLCs are used. Today, almost in every industries, not even a single industry is not there without the PLC. Every industries everywhere from the big industries to the manufacturing of even the small toys, everywhere they are using the PLCs. Understood? Some areas I have listed here, that is manufacturing and machining. Manufacturing and machining industries, that is to control in the big plants they are using the PLCs. Food and beverage processing, here you can see food and beverage processing, car park and train station control. This is the diagram of the car parking system. Here the PLCs are used. Then industries. Next, even packaging and palletizing. See here you can see the for the packaging also they are doing the using to the machines by using the PLC. Material handling, then textile, travel, printing also they are going for PLCs. Mining areas, mining industries also, even power industries, petrochemical or chemical industries. See, if you consider a large plant, you will be having so many function units. Understood? For example, in all the function units, if you consider one unit, there if you want to control and if you want to monitor the temperature, pressure, etc., therefore you will be having the PLCs there. By sitting in at one place, you can monitor entire plant of the industry. That is the advantages of the PLC using in the industries. Next, we will see the block diagram of PLC system. See, if you see the block diagram, generally in the PLC, the main one is CPU. CPU is your processor. For this, you'll be having the power supply and programming device. Programming device is where you will enter your program, okay, through your PC or handheld terminal unit or dedicated terminal, etc. like that. And this is your input module. Input module from where you sense the sensors or your input, okay, and output module. According to your input module and the programming, your output module will actuate or you control the outputs like solenoids, contactors, alarms, etc. And what are the major parts of the PLC? The major parts of the PLC system are, first one is CPU, Central Processing Unit. Below that you are having three main subparts, that is your microprocessor, your memory, your power supply unit. And then next one is your programmer or monitor. Then you are having the I/O module and the last one is the racks and chassis. CPU. CPU is the brain of the system which has three subparts. Microprocessor. What this microprocessor will do? Microprocessor, it will carry out all your ALUs, that is arithmetic and logic operations. The computer center, it carries out mathematical and logical operations, and also it will control the operations also. Next one is your memory, the area of the CPU in which the data and information is stored and retrieved. In the memory, you will be having the different types of memory: ROM, RAM, EEPROM, EEPROM, okay, NVRAM, flash memory, etc. Understood? So the input signal after sensing, understood, it will be stored in your RAM. Okay, in the RAM, it will be divided into input image file and output image file. The CPU, what it will do, it will fetch the input variables from the input image file. After processing according to your programming, then your output image file is filled by the CPU. Then again that data is given to your output module. According to that, your controlling variables of the outputs will be actuated. Understood? Next one is your power supply. In the power supply, you'll be having internal power supply and external power supply. Okay, internal power supply, this it provides to the CPU, because for the CPU it should be having between -5 volt to the +5 volt. Understood? From input module to CPU and CPU to the output module, it should be in the range of +5 volt to the -5 volt. And another one is you're having external power supply. This external power supply is the input signals which the input module is sensing. It may be +5 volt, +12 volt, +24, +122 volts. It can be like that. Even for the output modules also. Power supply is provided to the processor unit, input and output module unit. Power supply, it may be integral or separately mounted. It can be with the processor or it may be separate unit. Okay, most PLCs operates on 0 volts DC and 24 volts DC. Understood? Next one is your programmer or monitor. What is this programmer? So, to the PLC, if it want to execute, you should have some kind of program. You are writing the program in ladder logic. So from where you need to enter that program, you need some kind of programming devices. So programming devices are dedicated devices. They are used for loading the user program into the program memory, and the user can edit and to monitor the execution of the program of the PLC. And also it is used to troubleshoot the PLC ladder logic program. Some of the examples of the programming devices are handheld terminal, dedicated terminal, or your personal computers. These are the most commonly used programming devices for the PLCs. Next one is the input or output module. This input or output module, where it acts as the interface between the CPU and your real world devices, that is your input devices. For example, if you have sensed the temperature, understood, then temperature is the input signal. Understood? Then the input module is a mediator between the input devices and the CPU, which is used to convert analog signal into digital signal. There we will be using the rectifiers. Examples of the input module, that is input signals, are push button switches, contact switches, limit switches, and all your sensors, okay, etc. In the output module, it is the mediator between your output devices and CPU. It converts digital signal into analog signal. Some of the output signals are solenoids, relays, motors, displays, etc. In the I/O module, we will be using the electric isolation and signal conditioning. For electric isolation, we will be using the opto isolator or opto coupler for electric isolation, because CPU, it cannot handle much voltage. The CPU, it can handle only the range from minus 5 volt to plus 5 volt. Understood? What is opto-isolator, what is optocoupler and all, we will see in the next coming sessions. And one more is the racks and chassis. The racks on which the PLCs are mounted and the enclosures on which the CPU, PM and IO modules are mounted. These are the racks where the components of the PLCs, they are mounted on these racks. We will calling it as racks and chassis. Okay, these are the main components of the PLC. Understood? So before solving the multiple choice questions, now let us have a brief summary on today's session. First, we have seen what is the definition of the PLC. PLC, it is a user friendly and it is a microprocessor based computer. It is a specialized computer which we are using to control the industrial environments. Understood? Then after that we have seen why we need PLC. Why can't we use the relay only? Because the relay logic control as well as the PLC logic control both are doing the same logical computations. Same thing it is doing. Then why we are shifting from relay logic to PLC? Because it is having some advantages. First one is to reduce the human effort, and using the PLCs it is flexible. It can have a low cost for larger systems also. Like this we have seen why we need PLC. And what are some of the leading brands, history of development also we have seen how this PLC got developed. Okay, first in 1968 the PLC programmable concept was developed by Dick Morley in 1968. After that gradually it got developed and today almost everywhere they are using the PLC. Then we have seen some of the leading brands of the PLCs like Allen Bradley, then Omron, Mitsubishi. Okay, so many companies, Siemens we have seen. After then we have seen what is the applications where we are using. In almost all industries we are using the PLCs. Okay, in power industries, manufacturing, food processing, chemical, automobile, etc. Then after that we have seen what are the major components of the PLCs. It is CPU, it is the brain of the system. The CPU we are having microprocessor, memory and then power supply unit. Then we have seen the programmer or monitor, then IO module and racks and chassis. Understood? Now let us solve some MCQs on this session. The first question. The processor module of the PLC is where the dash. A. Sensors are located. B. Input connections are made. C. Ladder logic program are stored. D. Output connections are made. What is the answer? The processor module of the PLC. What we will be storing in the processor module? We are storing the ladder logic program or stored. So answer is C. Next question. Which of the following can be the output of the PLC? So what is the output to the PLC? Relay coils, solenoids, indicators, motors, lamps and alarms. If you observe the options, all the options are output to the PLCs. So answer is D. Which of the following cannot be an input that is given to the PLC? Input, which is not an input. Manual switches, relays, sensors and none of the above. Which of the following cannot be an input that is given to the PLCs? All are the inputs only. So the answer is D. The power required to operate the logic circuit of the processor unit is typically low voltage DC, high voltage AC, high voltage DC, low voltage AC. I have already told you for the CPU, you can have the power supply from minus 5 volt to the plus 5 volt DC. Okay, so that is low voltage DC. The PLC is used in dash machine tools, automated assembly equipment, molding and extrusion machines, all of the above. PLCs are almost used everywhere. So the answer is all of the above. I think you have understood the introduction to the PLC. Uh, Thank you for the listening, and we'll continue the other topics in the next session. Thank you.